Okay, good evening, everyone, and welcome to this online webinar on postgraduate studies within the BTCM group in the Civil Engineering Department at IIT Madras. My name is Dr. Ashwin Mahalingam, and along with several of my colleagues, I am here and we're going to give you a little bit of an overview of our group, the BTCM group, as well as the PhD programs and the PhD program and some topics that we have for which we are looking for PhD students. Okay. So let me go ahead and start. So the agenda for today's discussion, I'll spend a little bit of time talking about the BTCM group, its historical origins, what do we do, and so on. I'll show you a very quick snapshot of the faculty in our group, and then I'll talk a little bit about the PhD program. I'll then hand it over to my colleague, Professor Ravindra Gettu, to talk about this exciting new center that we created a couple of years ago called the Technologies for Low Carbon and Lean Construction Center, TLC2, which represents most of the cutting edge work that we do today in the BTCM group. And then several of our colleagues will introduce the research topics that they have put out there for which we are actively seeking MS and PhD students. So very quickly, the BTCM group, the Building Technology, Construction Materials and Management group, is almost 50 years old. It was, or it is the first group of its kind that brings together technology as well as management. It was so that we have three basic areas in this group. One area is on building physics, where we start looking at things like the sustainability of buildings, energy consumption, heating and cooling within a building, and so on. We also have a very, very strong thrust on construction materials, where we look at the strength, the durability, the sustainability of a variety of materials that we use in construction. And we also have a thrust in the area of construction management, where we look at planning, execution, but also at things like contracts, safety, quality, things like this. At the moment, we have 13 faculty members in this group, and we all have diverse expertise corresponding to these areas. We've had several people graduate from the BTCM group across the years, and most of them are very well placed in industry and academia, both in India and abroad. And many of them are in the absolute best organizations, corporate or academic, in these fields. So this is just a small picture of us and some of the faculty and some of our recent students in this group. Recently, and you'll hear a little bit more about this, we organized a TLC2 week, where we had a number of eminent international speakers as well as people from India who spoke and deliberated, discussed, along with, of course, all our students. So this is just a small snapshot of the kinds of events that we've organized at in the BTCM group. Okay. So very quickly, we have, as I said, 13 faculty in the group, and this is a quick snapshot of the faculty as well as the areas that we sort of work in. I'll start on the top right and quickly work our way down. So Professor Manu Santanam and Professor Piyush Chaunsali work in the area of alternative cementitious materials. Professor Radhakrishna Pillai works in the area of corrosion control and service life extension. Professor Koshi Varghese works on lean construction. Professor Benny Raphael works on construction automation and robotics. Ashwin Mahalingam, that's me, I work on building information modeling and integrated project delivery. Professor Murli Jagannathan works in the area of contracts. Professor Sivakumar Palniyappan works in the area of sustainable construction. Professor Nikhil Bugalia works in the area of digital technology simulation for sustainability. Professor Ravindra Gettu works in the area of life cycle assessment. And you'll see that sometimes faculty work in more than one area. So Professor Ravindra as well as Professor Kirtana work in the area of fracture and fatigue of concrete. Professor Aslam works in the area of computational materials modeling of cementitious systems. Professor Benny Raphael, who also works in the area of construction automation and robotics, and Professor Manu work in the cutting edge area of 3D concrete printing. And Professor Ravindra Gettu and Professor Surender Singh, who is also with our transportation group, work on recycled construction demolition waste materials and how we can reuse these materials for the construction of pavements and several other structures as well. So you can see we have a series of faculty who work in various areas relating to construction management, automation, process improvement, on construction materials, whether it's recycling, advanced cementitious materials, 3D printing, as well as in the area of building automation, so construction automation. So in the BTCM group at IIT Madras, we of course have a dual degree program. We also, which is for our undergraduates who wish to stay an extra year and graduate with a master's. We have a regular MTech program where students enter through GATE and do a master's in building technology, construction materials, and management. We also have a user-oriented program where industries such as L&T sponsor students. We have about 30 students a year. They have a mix of civil, electrical, mechanical background who spend 2 years doing a master's, but this master's has a bit more of a practical focus where we combine technology, management. The projects at the end of this are a little bit more field focused and so on. But perhaps of more interest to this group are our two research programs, the Master of Science Research Program, as well as the PhD Research Program. So the way these programs work is there is an admission process, the admission portal, you can apply on the admission portal to either of these programs. There will be an initial shortlisting followed by an interview. The interview will be accompanied by a written test as well. And selected candidates will then be let into the PhD or master's program. These programs will commence in June or July of this year. So the recruitment, the interviews will happen in early May. The results will be notified, and by June, July, candidates will be enrolled into this program. Typically, the program, the master's by research, the MS program takes anywhere between 2 to 3 years. There are a few courses that you will take right at the start, and then there is a research-based thesis that you will develop. The PhD program typically takes about 4 to 5 years. Typically, the first year is spent on understanding the problem and taking a number of courses that will help you develop expertise in that area. Post the coursework, there will be an examination, a comprehensive examination to ensure that you have enough breadth and depth in your area of interest to take on the PhD. And beyond that, it is typically a 3 to 4 year process where students define their problem a little bit more clearly, give a research proposal seminar, and then go about collecting data, doing analysis, give a few seminars along the way, but finally defend that analysis in front of a committee. Okay, so this is in a nutshell how the research programs work, the Master of Science and the PhD program. And to apply to these programs, you will have to apply through the IIT Madras research portal, the details of which are given here on this slide. So do apply, and based on the applications, you may be shortlisted and asked to come here for an interview. The interviews this year are going to be in person at IIT Madras. In previous years, because of COVID, we've done them online, but the expectation this year is that the student will come to IIT Madras, take a test, go through the interview, be admitted into the PhD program. And once you're admitted into the PhD or the MS program, it's a 2 to 5 year journey in terms of completing that degree. Right? Now, in terms of who can apply, of course, we accept applications from people with a background that relates to the kind of work that we're doing. So backgrounds in civil engineering, backgrounds in architecture, backgrounds in related fields. But we are also interested in a series of topics that we currently work on. And what we'd like to do is to give you a little bit of an orientation in terms of the kind of work that we do in the BTCM group and specifically in the TLC2 center. So I'm going to now turn it over to my colleague, Professor Ravindra Gettu, to talk about the Technologies for Low Carbon and Lean Construction Center.
So hello everyone, it's great to be with you. Thanks Ashwin for telling us about the Building Technology, Construction Materials and Management division and the program and the faculty. So as Professor Ashwin said, we had this opportunity of starting off this Center of Excellence. It came about because IIT Madras was designated as an Institute of Eminence. And due to this, we had a large funding for pushing research, selecting research initiatives that could be at the world class or would reach world class soon. And we were very fortunate to have a Center of Excellence selected under the scheme on technologies for low carbon and lean construction. So this is with BTCM faculty and some other faculty also who have allied interests. And our focus is on developing technologies to reduce the waste in construction, in all aspects of construction, material, process waste, and so on. So when we say low carbon, it is low carbon footprint. We want to reduce the carbon footprint. We want to reduce the environmental impact. And when we say lean construction, is reducing wastage of all sorts, not only material, but time, productivity, transportation, and so on. So we want to reduce everything, and we want to reach a situation that construction would be something that will happen with zero environmental impact and zero wastage. So this means that we have to bring in science. We have to look at the fundamentals of material science. We apply this basically to concrete. Most of us work on concrete, but not restricted to concrete. We want to accelerate, automate way construction technology is done. And not only that, we want to change policy. We want to make sure that what we develop in our labs and in our research centers reaches practice. That is the way that we believe a sustainable construction ecosystem will develop in our sector. So our focus, as I said, is to reduce wastage, reduce carbon footprint. So we want to recycle and reuse material waste, not only waste coming from our sector. We would like to use advantageously waste coming from other sectors as well. For example, fly ash or slag from other sectors are used beneficially in construction. We want to minimize the process waste. Any wastage coming from the construction, we want to reduce. Anything related to the process of construction in terms of wastage, we want to reduce. That is what we believe will reach the sustainable way of construction. So we start off with materials. Say if you have a waste material, we want to choose and find out which is the right material to use, design the mechanical properties with those kind of materials, advantages for using in say structural concrete or use any other concrete application or any other construction application. We design not only for mechanical properties, but also durability and sustainability. Durability is something that you will hear about from the people who are talking after me. Durability is something we believe has to be an essential part of sustainability. Sustainability cannot be without durability. As far as our construction sector goes, sustainability is not only environmental impact, but social impact and economical impact that we will want to also consider. This cannot happen without automation, without the right type of contracts, without the right type of selection of construction methodology and contracts. Then we will have a durable system. If we have to, we will have to see how to repair, how to extend the service life. Eventually, when the structure has to be demolished, we want to do it right. We want to see if elements can be deconstructed, if elements can be reused. We want to look at policies and practices for waste management. Some of our faculty are working on that. And we would like to recycle, as I said. So this gives a glimpse of the focus of our center. And now you will hear from different faculty members who have particular research interests or requirements in mind. And we are seeing how PhD students can come on board with these projects in mind. Okay, so I'll pass on the stage to Professor Radhakrishna Pillai, who will talk on the current research topics that he is interested in, and then other faculty members will also look at. So this will give you an idea of what are the areas that we are looking at and which professors are looking for students, so that you can even reach out to them as far as BTCM and TLC2 are concerned.
Hi, this is Radhakrishna Pillai. I'm actually looking at two research projects right now, looking for students to work on two research projects. One is looking at how we can control corrosion in concrete structures for a long term. Basically, like we have a lot of structures now which is experiencing corrosion, and we want to control, like do something to that structures and stop corrosion for the next 50 years. So this is something where we are looking at using the technology of galvanic cathodic protection, and we're trying to develop a new type of anode which is specifically designed, or which can be designed for extending the life of the concrete structures by another 50 years. So it's a challenging project. We're looking at both cement chemistry, electrochemistry, all these aspects will be put together in this project. Another project here is to look at how to design concrete structures for a service life, but not looking at the element level durability design, but to look at the structural level durability design. So these are the two projects which I am interested in right now. Next is
Hello everyone, thanks for joining. I'm Piyush Shausali. My primary research area is in the field of low CO2 cements, and specifically I'm looking at basically durability studies on lab synthesized calcium sulfur aluminate light cements. So we had success with synthesizing this low CO2 cement in the lab, but at very small scale. Now, since we have a rotary kiln, which is first of its kind in India, where we would like to scale the manufacturing of the CSA cement using locally available materials. So I would expect someone to manufacture this cement in large scale using the locally available materials and look at the durability of the concrete, which will be made using this CSAB cement. And please feel free to refer to the published papers in this area. And now I would pass this to Ashwin.
Our colleague, Dr. Nikhil Bugalia, is currently attending a conference in the United States. So, but I wanted to briefly introduce a project that he is very interested in working on. Today, there's a lot of technology being employed in the construction process. And there's a lot of technology that's being employed in the construction process. And one of the cutting-edge tools that we are now using in construction is virtual reality and augmented reality techniques. The idea is if you want to train people to be to work safely, then it becomes very difficult to train them on construction sites because, of course, on construction sites, you are already facing safety hazards. You can train them theoretically in a classroom, but again, that's just theoretical knowledge. But if you can use virtual reality to give workers an immersive experience on the construction site, then it's quite possible that they will learn good safety practices so that when they get onto construction sites, they actually work in a very safe manner and the safety performance on all our projects improve. So this is an area of research where Professor Bugalia is interested in looking at students who can help not only build virtual reality-based models of construction, but also conduct research on how would we train workers in these kinds of virtual reality environments in order to make them safer when they get onto construction sites. That I'd like to now ask my colleague, Dr. Murali Jagannathan, to speak about this.
So hi all, and thank you very much for joining us today. My name is Murali Jagannathan, and my area of interest is in construction contracts and legal issues and dispute resolution. So I have two topics to offer. The first one is on opportunistic behavior and construction dispute. So if you look at any construction dispute resolution process, there are a lot of things that get into this process which ultimately can be successful or may not be successful. Now, of many things that get into the process of dispute resolution, when there is a kind of an opportunistic behavior by any party involved, not this party or that party, any party involved in the process, there is the time that takes for the dispute resolution, it increases dramatically. Ultimately, you're going to settle at some particular number which you have in your mind, but you start off with a larger number or start off with a unreasonable kind of a proposal. So that's where time is consumed to resolve the disputes. Now, having said that, certain degree of opportunism is definitely inherent in this process. We cannot, ultimately human beings are involved here. So where is that thin line? So what is, and is there any way through which we can measure this opportunistic behavior and try to come up with some kind of a solution or some kind of a metric for this? And for that, what all would be the factors that would be involved when we are trying to say opportunistic behavior of the parties, and why does it happen and things like that? So it involves a lot of work both in terms of qualitative understanding of the problem, and also it will also involve quantitative research, quantitative approaches to arrive at a solution. So those who are interested in this area of dispute resolution, contractual claims and management, this is something that you can look out for. The second topic is on a framework for implementing lean and sustainable construction practices. So Professor Gettu was telling that one of the fundamental objective of TLC2 is getting things to field, getting things to practice, getting the research to practice. So now lean construction is something that is being discussed for many years, many decades. But if you see again, if you look at the adoption, it's only at certain pockets you can find it. Find people adopting lean construction into their projects. Now again, there's no straightforward answer to say why people are adopting this or why some people are not adopting this. So this requires a holistic understanding of various factors involved, right from technical issues, legal issues, contractual issues, and also some people say that it is very easy to prescribe something in the contract and say that you use that and you ask the other party to implement lean construction of the project. Again, it's not so easy given the way we draft our contracts. So there would be a certain amount of artificial intelligence based natural language processing tools that the researcher would be expected to use here to assess whether are we, in terms of contract, are we ready to implement lean practices, and also what would be the other things that come into this process. So this is something that I'm looking for in the second topic. So can write to me, and if you have any further questions on this, or you can post your questions here. So move on to the Dr. Ashwin.
Yeah, so I am interested in issues of adoption and change. So you heard several of my colleagues talk about sort of wonderful ideas, innovations that can help lower the carbon footprint of construction. But not all of these get implemented in the field, in practice. And so I'm interested in understanding what we can do to accelerate the adoption of technology. I look at it from two levels. One is from the level of the business, and the second is at the level of the project. So in terms of the level of the business, there are what we call institutionalized behaviors or repetitive behaviors that people undertake, so that the same set of systems and processes get propagated from project to project. And I'm interested in understanding how engineering firms or businesses change their business models to work more sustainably. So that's one topic that I'm interested in at the level of the organization, at the level of a construction firm or an engineering firm, or even a firm that supplies construction materials. The second area I'm interested in is more from the level of a project. In order to really be sustainable, we need architects, civil engineers, mechanical engineers, electrical engineers, everybody to come together and coordinate and design and construct these projects if we want to reduce both the embodied as well as operational carbon footprint. And that is not always easy. In fact, it rarely happens in practice. So I'm interested in understanding how do we coordinate better, and can we benchmark the most sustainable projects and try to understand how we can coordinate better among various specializations to improve upon these benchmarks. So if you're interested in a more organizational perspective on research in construction, then please contact me and we can discuss your interest on these projects. I'd like to now ask my colleague Dr. Aslam to speak about something.
Hello everyone, I'm Aslam Kunji Mohammed. So I'm more on the material side. I work mostly on very fundamental aspects, mainly looking at how cement hydration happens at the molecular level, at the atom scale. So the research topics that I do are mainly based on some techniques like molecular dynamics and density function theory calculations, where the idea is to understand, cement hydration, the main product of cement hydration is calcium silicate hydrate. So in this topic, we know this is the most manufactured nanomaterial in the world. We know how its atomic structure is in the final form that gives the concrete its strength and so on. So in this research topic, I would like to see how actually when cement is mixed with water, how the different atoms will behave in the solution, and then how these ions will come together, form clusters, and eventually nucleate and form the final CSS structure. So this would involve some basic understanding of chemistry, physics, as well as if you have some background in material science, that will also be useful. So if you have any questions on this, please let me know or post it on the chat. Thank you. So now I will give to my colleague, Professor Keita.
Hi everyone, I'm Kirtana Krupakaran. So I work on the area of mechanical behavior of construction materials. So like my colleagues previously who were working on materials, they're looking into developing different types of materials. And in order to actually get into the structures, we have to know the mechanical behavior of these materials which have been developed. So I mainly look at how do we understand the mechanical behavior, how do we understand its structure behavior, and so on. So this particular project which I have mentioned here, which is investigating splitting and spalling fracture in steel fiber reinforced concrete segments. So here, to give you a brief background on why this topic is introduced. So you see a picture, rather GIF, which is showing that this is a tunnel boring machine which is trying to bore the earth. And on the rear end, there is a precast concrete segments which are being mechanistically arranged in a automation fashion. So here what is happening is, as the machine is moving forward, the jack thrust, the jacks from the tunnel boring machine are using the rear end precast segments as a reaction, and they are moving forward. So when this reaction is forced upon on these segments, there's a lot of cracks occur. So these cracks are mainly happening due to the splitting, and these are mainly called as splitting and spalling fracture. So if you see in the figure below, you see that these are the jacks, that is thrust jacks. Just below them, you see that the bursting stresses occur and it leads to splitting fracture. And in between these two jacks, you see that spalling stresses occur and lead to spalling fracture. So in India, in order to mitigate this fracture, especially in the construction stage, the steel fiber reinforced concrete precast segments are being used. And in India, we've just started to use these steel fiber reinforced concrete. Conventionally, we were using reinforced cement concrete precast segments. Now, it is very important to understand the behavior of these segments under these jack thrust forces, because these are highly concentrated loads, and it is not always possible to do experiment and understand, because these are huge segments. So we also have to do a numerical analysis to understand its behavior. So this work will have a combination of both experimental and numerical and also analytical work combined. So if you're interested in this topic, feel free to approach me via email or post questions. Thank you.
Yeah, okay. So this is Ravindra Getu again. So if you wondered why concrete cracks, you should probably take up this project. You find cracks in concrete everywhere, but sometimes cracks happen even in compression when they should not be cracking in compression. So there is new information on why this occurs and what happens when compression and tension occur together. So there is a very famous professor called Bajan who has come up with a new way of looking at fracture. And we are going to see how to extend that, analyze that further, do a test like what you see in the picture there, where you have compression and tension leading to cracking. And with this, we believe we can understand cracking that can occur under compressive stress, splitting, spalling, and so on, like you would have in that segmented tunnel lining that Professor Kirtana talked about, bearing in bridge piers, diagonal shear of beams. So many cases we have cracking like this. This means that the student would have to go to the lab, do some tests. I always have fun breaking stuff. So we need students who want to break things and then analyze why these materials break. We want to particularly look at fiber reinforced concrete, which is again a novel material where you put the reinforcement along with the concrete. And we want to use fun techniques like digital image correlation and finite element methods so that we can understand how cracking occurs under these stresses and how we can go to application. The next topic is also something that I would like to be involved with Professor Radhakrishna Pillai, where we are looking at a framework for assessing sustainability in a concrete structure. In a concrete structure, there are infinite possible design mixes that you can use. infinite possible ways of designing elements, beams, columns, and so on. So we want to know if we can bring together a framework, put together a framework which will help us compare not only different materials, but different structural systems and see if one is more sustainable than the other. So this would mean that we would help the usage of waste materials, low carbon cement, reduction of cement, the ordinary Portland clinker in the concrete. Not only that, but we will also look at durability and service life extension. As I mentioned before, durability is very important for sustainability. Something that has a very low carbon footprint and just lasts a few years is not something we want. We want something to last for a long time. And this is something that we want to incorporate in our methodology. And we feel that if we do it right, we can construct structures with reduced material usage, with longer durability without affecting the structural requirements. And we might have to look at local aspects as well, like the lack of water. Water is something that is very precious to us. And this is something that could also come into sustainability assessment. So we want a student who is willing to learn new techniques, who cares about the environment, who wants to make the world a better place. And that is someone who we need for taking up this work on sustainability assessment.
So those are the topics those are some of the topics that we are all working on. Our suggestion is that if you are interested in a master's by research or a PhD in the BTCM group, think about the topics that we've mentioned and see if you'd like to align yourselves with any of these topics. It would be to your advantage if you could do a little bit of preparation to understand a little bit of what the topic is and perhaps come with some kind of an outline or a plan of action of what you might do to tackle this topic. But at the same time, we are not closed completely to other ideas as well. So if you have an idea that you're very passionate about and you feel that it fits with some of the interests that you've heard today, then absolutely. But do come prepared to the interview with an idea that you want to work on, either one that you've heard today or something else, and where you've done a little bit of background work in terms of a broad outline of what you would like to do. So with this, we will open it out to questions. I believe there are a number of questions that have come up on YouTube. So we'll try to answer as many of those as we can.
One of the questions is the requirement for GATE score, whether it is necessary or not. Maybe you would want to repeat that it's not necessary for a PhD.
Yes, so for a PhD, for a PhD, there is no necessity to have a GATE score. You can apply even if you've not written GATE. I believe for the Master of Science, the score does not matter, but you have to have written GATE. So yeah, whether it's a high score or a low score doesn't matter. For a PhD, you do not need to have written GATE at all. Yeah, so if you would like to learn more information about what we are doing, the Technologies for Low Carbon and Lean Construction Center has its own website. It's tlc2.iitm.ac.in, or you could simply go to Google and just Google TLC2 and IIT Madras, and you will find that the center's page comes up, and that tells you a little bit more about who we are, some of the work that we've done, some of the work that we are planning to do. So please do look at that website, because that will give you a good orientation of what this group is collectively looking at in terms of research directions.
You put a problem statement. You could, yeah. So also for PhD, if you are getting shortlisted and coming for interview, you can look at the topics which we discussed, which is also provided in the announcement page on the department website. So you can look at, and then based on the topic of your interest, you can probably prepare a 1-page or something write-up on what you really want to work on. And this is very important for the PhD interview. So we would like to have students, with well-prepared kind of background on what you really want to do.
There's a question about the stipend. There is a stipend for PhD, and it varies. The standard stipend is about 30,000 rupees per month, but there is also a Prime Minister's fellowship where students can get about 75,000. There are multiple schemes under the Prime Minister's fellowships that you can avail. So if you are a very good student, there's no reason to stick with a lower stipend. You can aim for a higher stipend. And the stipend is given for about 4 to 5 years. And obviously, you have to keep a good academic record while you are here doing the PhD. There was another question, how does sustainability and structural engineering come in? So that was precisely what Professor Radhakrishna Pillai and I were thinking of when we proposed our topic, where we want to look at sustainability at the structural level. Not just the material or not just one aspect, but the whole structure. We want to assess the structure and see if one type of structure, one type of material in a structure would make the structure itself more sustainable or not. So structural engineering is very much related. It is the end of whatever we do in our research. So we expect it to be part of sustainability. Not much work is being done at the international level, not only in the Indian level, but international level. But this is what we want to work on. So we certainly are interested in looking at sustainability at the structural engineering level.
So another question is, which project is for MS research? Actually, all these topics we will, if we find a good student, there is a possibility of both MS and PhD position. So it's not restricted to either MS or PhD. If you are interested, please do apply and we will have openings.
Just to clarify on that, each of these topics is a very large topic. And therefore, an incoming student will also have to define how they want to approach that topic. So there is space for multiple people within each of these topics.
Another question is whether the PhD interview will be offline or hybrid mode. I think this time we are going only offline. So there will be no hybrid mode.
Offline, in person, we expect you to, if you have been called for the interview, to come here. Physically, there will be a computer test, but it will be done in our premises. Post which there will be an in-person physical interview. And the interviews will be spread over 3 days, so you will be called on any of those days. But you will be given at least 2 to 3 weeks notice, so you'll have ample time to make your travel arrangement.
There was a question of how to get PMRF. You can Google, there is a lot of information in the website. There is a call for these fellowships. Also, once you enter the program, there is the possibility of getting the fellowship in your second year. So you can try right away before joining us, or even after joining us. If you're doing very well, you would be able to get the PMRF in your second year. Well, Edward wants to know if you can apply for other topics. Certainly, these are topics that we are interested in, but you could come up with interesting topics. And as long as we are able to support you and guide you in that, we will certainly do it. Many of our students come with their own ideas and they turn out to be fantastic PhD. So it certainly is possible.
For more than one topic. Yeah. So
you can.
Sure. So I think it would not be to your advantage if you came to the interview and said you are ready to work on any topic, because we expect a little bit of focus. But we understand that you may not be able to focus on just one topic. There might be a couple that catch your fancy, in which case that's absolutely fine. But do a little bit of homework and come with some sort of idea in terms of what your interests are, what topics you're interested in, and maybe a little bit of background knowledge on these topics. It is also possible for you to come to the interview with maybe a one-page sort of research statement or research proposal on that topic that helps us understand how you've thought through this. So we'd encourage you to spend a little bit of time writing a very short one, maybe 2-page document on your research interest. It's not compulsory. You don't need to do this, but it might help you think through the research. It might help us also better assess your clarity of thought and how committed you are to the problem.
Kalpana has a question regarding grinding aids. Although it's not explicitly mentioned here, but definitely it's of interest because not much work has been done in this area. So if you can do some prior art research, and by the time you come for interview, if you can prepare, a statement or a problem statement, as Professor Pillai mentioned earlier, that will be really helpful. So yeah, definitely you can take it forward with some background on the topic.
Then I want to mention, if you have any interest in any of the topics of in which we work on, please contact the faculty member directly. You don't need to wait for the interview call. You can start contacting right away and then build on a proposal. So by that interview time, you can actually come up with a fairly good idea about what you would really want to work on. So that will also improve your chance of getting admission.
The question about interview is going to be offline. This time we are having offline interviews.
Yeah, another question is on whether corrosion of steel structure can be a topic. I mean, I'm not really looking into steel structures right now, but yes, if you have a very clear-cut idea on what you really are looking at, we can talk further and then see if that can be a topic. Yeah, all interviews this time is offline. There is no interview on online mode, whether it is for MS or for PhD. And when can we expect the short list of the students? Maybe sometime in April.
Yeah, so the plan is that I believe the portal closes March 31st is the last day for application. So it'll take us about, I would say 10 to 15 days maximum to process the applications, do a initial filtering and then communicate to the successful applicants. So to the ones that we're calling for the interview. So I would expect somewhere by about the middle of April is when you should expect a response to the application. And the interviews will then be held most likely at the beginning of May. So that will give you somewhere between 2 and 3 weeks to make your travel arrangements to come to IIT Madras.
So another question is there a written exam based on a specific topic we are interested on? So the written exam, if we are conducting, that will be based on the general BTCM or the materials. If you are interested in one of the materials related topic, it will be on concrete materials. Basically looking at your undergraduate and master level knowledge in that area, not specifically to that particular research topic. It's for the materials area or management area. Two exams we will conduct if at all we do that.
Yeah, no, we are planning to conduct exams and you will be given a choice. You can either pick the material stream or you can pick the construction management stream. And your questions will be, in both cases, there will be a mix of general aptitude questions as well as subject matter questions in that domain. And the idea is not to get very deep or very, to ask you too many complicated questions, but to see if you have, for instance, if you're applying to the PhD program, if you would have the basic knowledge that we would expect out of a master's student. So if you're looking at how you might want to prepare for it, for the aptitude, there's really no way of preparing. It's an aptitude test. For the subject matter test, maybe just brushing up what you would have studied in the master's program, either in the area of construction management or in the area of structural engineering or construction materials would be probably a useful way of preparing.
There's one question on part-time.
Yes, we do have an option for doing a part-time, PhD. The expectation is that typically these are for people who may be working professionals who might also have a job but want to do this PhD in association with the job that they have or in parallel to that. The interview process will be very similar. You will still go through the test. We will still do the same assessment. But if you are selected and if you wish to come part-time, the expectation is that you spend 1 semester on campus. So that you take leave from your employer for 1 semester, come to campus and complete your coursework. So typically we do about 4 courses for the PhD. A normal PhD student would do something like 2 or 3 courses in 1 semester and perhaps the balance in another semester. For a part-time student, you can probably cram all of that into 1 semester, but that is the expectation that you come here for 1 full semester. Once you fulfill those requirements, then you go back to your job, you interact with your advisor, you come back periodically once every 6 months for a review meeting, and you can continue your PhD in that mode. Typically, as you would expect, a part-time PhD takes a little bit longer because you're balancing your PhD with pressures and responsibilities from your job.
There's also one thing about part-time that your residence has to be within 100 kilometers or some kind of catch is there. So you have to look at the ordinance for that rule, but we can see how to.
And there is also, just to clarify, there is also no stipend for the part-time. The stipend or the PMRF, all of that apply for the full-time PhD program. But there is no restriction. I mean, if you are a working professional, you want to apply part-time, that option does exist.
There's also another program called PhD External, where your current organization supports you and you can pursue PhD here. There, the restriction on the distance between the institution and the residence is not.
Correct. And there also in the external mode, where you are a sponsored candidate being sponsored by your employer. So in part-time, you may be employed, but your employer may not be sponsoring you. In the external case, the employer sponsors you, but you still have the same 1 month, 1 semester residential requirement, where you come here, stay with us for a semester, finish a whole set of courses, and then go back to your place of employment. Yeah, so I think there is a question on what streams can apply. I think the best way to answer that is if you go to the research portal website and look at our brochure, against each area within civil engineering, there will be a minimum qualification in terms of what kinds of degrees we expect you to have or what kinds of degrees are eligible for application. So generally, if you are looking at, I mean, some people have done degrees in mechanical engineering, others maybe in urban planning and architecture. And if you're worried about whether that would make you eligible or not, my suggestion is go to the brochure and it will very clearly state what areas we will accept, and anything outside of that area is unfortunately something that will not make the cut as far as the applications.
So actually, like for this mechanical engineering, that qualification, people with those qualifications, in structural engineering, it is allowed. So you can actually go through the ordinance provided in the research.iitm.ac.in brochure. So now Professor Piyush has put that in the chat box, the link for that document. So it is possible, but may not be directly in BTCM at this moment.
There is a question about other positions. So obviously, you can reach out to the concerned faculty if you are looking for, let's say, a postdoc or a project associate. But right now, we are focusing on MS and PhD admission.
There's a question, what's the difference in MS plus PhD and PhD only? So this MS plus PhD is not the direct, it's a direct PhD program where you will take a bit longer than the regular PhD program. So first you have to finish the MS, not the MS degree, but there are some requirements.
Yeah. So this MS to PhD program is intended for undergraduate students who are looking to directly apply into a PhD program. So most people will probably already have a master's and then they apply directly for a PhD, or most undergraduates would just apply for the master's by research. But this is a program where we allow undergraduates with exceptional performance in their bachelor's program to apply directly for a PhD. And in that process, they will naturally take far more courses than the typical PhD student does, because of course they don't have the master's background, and then continue with their PhD. So instead of doing 2 degrees, a 2-year master's, perhaps followed by a 5-year PhD, which would take a total of 7 years, using this combined master's plus PhD approach, we expect that you might get the PhD in about 6 years after your undergraduate degree. But if you already have a master's, then you can apply directly for the PhD.
Another question is from Om Rastogi. So this is about whether getting an admission in MS program without sponsorship is possible without a GATE score. I think for getting admission, you need to have a GATE score. Whether you get a assistantship or not depends on the rank which you get.
Correct. Yeah.
So to get into the program, you need to have a GATE score.
Or to apply to be shortlisted, or for your application to be shortlisted for you to appear for the interview, a GATE score is a minimum qualification. So we are nearly at the end of our hour, but if there are a few more questions, we can certainly take.
Prabhash is asking, during my MTech, I already work on fly ash and silica fume in high strength concrete. Can I continue on this topic? Yes, definitely you can continue, as long as we are able to match with the interest which we have here.
For the MS plus PhD. For the MS plus PhD, the 3 semesters roughly of coursework that is required. So yeah, I believe it's about 3 semesters worth of coursework that is required, and that will be relatively full semesters of courses in that sense. Whereas for a regular PhD student, you would do courses over 2 semesters, but you would not have a full course load. So you would also have time to start thinking about the research. Right? For the MS plus PhD, we invest in the first year and completely we identify candidates with high potential, but we take the first year to invest in them, to skill them to a point where they can actually start looking at postgraduate research. And then their journey starts. Well, we do have at IIT Madras, we have a big thrust on hydrogen. In fact, we've just set up something called a Hydrogen Valley project, where there is a lot of hydrogen related innovation that's happening. Some of our faculty in this area are from chemical engineering. So if you're interested, you should look at chemical, also at applied mechanics, and see if your background fits there if you're interested in working in hydrogen.
It's the minimum CGPA cut. CGPA.
Yeah,
There is.
the expectation is, yeah, well, it's 60% is the expectation in your earlier degrees. But yeah, so you can convert your CGPA. So typically a CGPA of above 6 on 10, equal to or greater than 6 on 10, should be eligible for the interviews.
I would suggest, I have just shared a brochure. Please go through the brochure carefully, and it has all the eligibility criteria which is required for MS, PhD. Also, you will get a sense like what are the different modes. It will give you more clarity. So that is also available on the research portal, admission portal, and also I have shared here in the chat.
So, Abnod, thank you all for taking the time to attend this webinar. We are excited to meet some of you, and hope that some of you will join our program and help us conduct cutting edge research. So please think about what you heard today, go and do a little bit of background research, and please apply before the deadline on March 31st. So all the very best, everyone.
Feel free to contact us if you have any questions via email.
Okay, thank you and good night.